For topic 6, we're going to look at how to solve a quadratic linear system. A quadratic linear system is whenever you have a parabola, so something that looks like this, and a line, and you're looking at their solution. So in this picture here, I wouldn't have a solution because the parabola and line never cross. In this scenario here, I would have one solution because there's one intersection point. And in this third scenario, I would have two intersections, so I would have two solutions. So the steps that you're going to go through are these 5 steps. First thing you're going to do is you're going to graph the first equation, then you're going to graph the second equation. Make sure you show your tables, make sure you show labels, make sure you put a scale on your graph. All of those different things, label the axes, are important. Third step is to figure out the intersection points. So if they occur, you're going to figure out if there's one intersection, no intersections, or two intersections. Make sure you label them. And then you can check your solutions a couple different ways. You can use the calculator. You can use that second trace intersection feature in your calculator, which I'll show you. You can use the table in your calculator to make sure that both points occur in the table. You could also just algebraically check by taking whatever solutions you have and plugging them back into both of your original equations and making sure they work would be another check. And then the last thing that is often forgotten is stating your solution. So just make sure that you always go back and state, here are my solutions. So that could be, a point taken off if you didn't state your solution. So always make sure you remember to do that. So let's go ahead and do an example. So the first thing I'm going to do is I'm going to identify my two equations. So the first equation here I know is going to be a parabola because it has an x squared in it. So since it's an x squared, it's going to be a parabola. Where the second one I know is going to be a line because it's just an x to the first. So when I graph the parabola, what I'm going to do is I'm going to take this equation and I'm going to put it in my calculator. And if you remember, parabolas are U-shaped, so they have symmetry. So that means when I go into my calculator, I want to look in the table in my calculator where I have symmetry. So I need to figure out that vertex or that middle point. So first thing I'm going to do is I'm going to go into the calculator. I'm going to go to y equals, and I'm going to clear out whatever I have, and I'm going to enter that in. So x squared minus 6x plus 6. And I'm going to go ahead to the table, so second graph to get to the table. And you need to scroll through the table until you see symmetry. So at this stage, I'm starting to see symmetry because right here, I see as my vertex because then it starts to repeat the y values. It goes -2, 1, 1, 6, 6, 13, 13. And that's going to be enough if you just go up to really 6 because that's all it's going to fit, would be perfect. So let's go ahead and record that table. So remember, we have the vertex in the middle, so the vertex is 3, -3, and then after that is when the y values start to repeat. And if you plot like 7 points, that's good because that'll get you a nice U-looking parabola. So I go ahead and I'm just copying down that table. And you can see your y values start to repeat. So then on my graph, remember I said we have to label our axes, draw in the axes if they're not drawn in. Put a scale on there, so I'm just going to go up by 5. So 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. And then I'm going to plot my points. So I have 0, 6, 1, 1, 2, -2, 3, -3. 4, -2, 5, 1, and 6, 6. I'm going to connect those and make those look as U-shaped as possible. Make sure you have arrows and make sure you label. So the first part's done. The second part then is to graph the line. So we have the line y equals x minus 4. And when you graph the line, you can just look at what's the slope. So the slope's 1. So that means it's 1 over 1, which means up 1 to the right 1 since it's positive. Y-intercept's -4. However, if you wanted to, you could go into the calculator and enter that. So you would have, I'm going to just put it into y2. So I have x minus 4. And then I could go to the table. And when I go to the table, I would just copy down the same. So like, if you remember in the table here, I copied down this section here. So from 0 to 6, because I wanted that symmetry with my parabola, I would just copy those same exact values down. So you would copy 0, negative 4, 1, negative 3, 2, negative 2, 3, negative 1, 4, 0, 5, 1, and 6, 2. You can copy them, you don't have to. I'm not going to bother copying them. I'm going to use the y-intercept and slope, but if you want to copy them, you can. So then what I'm going to do, though, go back to my graph. I'm going to start at negative 4 for my y-intercept, and I'm going to go up 1 to the right 1, up 1, right 1, up 1, right 1, and just keep doing that until you get enough points, and make sure you use a ruler, and you will connect those points, and you should have arrows on there. And we also need to make sure that we label. So arrows and label y equals x minus 4. So then you can see we have two solutions for this particular problem. We have two intersection points, one right here and one here. So remember, you have to state your solutions. So we have 2, negative 2, and 5, 1 as solutions. And remember the check. That was one of our steps here. So there's a couple ways you can check. You can take these points and plug them back into each equation. So take 2, negative 2, plug it in to the line. Take 2, negative 2, plug it into the parabola. Take 5, 1, plug it into the line. Take 5, 1, plug it into the parabola. So it's 4 things. I would recommend just using your calculator. So on the calculator, I have both equations entered. If I look in the table, you can see that my solutions of 5, 1 worked because I have 5, 1, 1. So you can see the y values are the same. So that means it's the solution. And also 2, negative 2, because negative 2 is repeated for the y values. So that's my other solution. So that's one way. But the question is, what if you get decimals? What if you don't get whole number solutions? How do you check them then? So what you need to do then is you go to the graph and you use that second trace feature. So I have my two equations graphed, my parabola, my line. And then what I do is I go to the trace. So I hit second because I want to calculate something. So second trace. And then you want to find the intersection. So number 5. And this is where the little flashing thing here, you got to take it and put it near whatever intersection. So let's say I want to find this intersection first. Hit enter 3 times. So we get 2, negative 2. So that one checks out. And then I repeat the process to verify that other intersection point. So second trace, number 5 for intersect, scroll over till I get close, hit enter 3 times to answer all those questions. You get 5, 1, that verifies the other. So again, to check in the calculator, I went to second trace, number 5 for intersection, and then I hit enter or move. First I move to intersection point, then enter 3 times. And that's it.